All right, so today we're in section 8.3, Quotient of Powers Property. If you remember back to yesterday, what did we learn yesterday? What did we learn? Product of powers property. Okay, literally we're taking out the word product and putting in quotient. So product of powers property, if you remember what we learned yesterday, we learned if you're multiplying numbers with the same base. All right, so let's say we have 4 to the 5th power times 4 to the 7th power. If we're multiplying, and we say exponents that have the same base, everybody agree that these numbers have the same base? What can we do to the exponents? What did we learn yesterday? Just tell me. You can add them. 4 to the 12th power. All right, what if we're raising a power to a power? So 4 to the 5th power, and now we're raising that to the 7th power. How could I work that? Yes, 5 times 7 now. The parentheses are important, so it doesn't look like a 57. And it's going to be 4 to the 35th power. This is something that we're not evaluating. You don't have to write on your paper 4 times 4 times 4, 35 times. Okay? That's not what we're doing. All we're doing is simplifying powers. So with product of powers, same base, we add the exponents. So if we're transferring over this concept into quotient of powers, does anybody remember what operation is quotient? What am I doing when I'm finding the quotient? What am I doing? I'm dividing, okay? So when I'm dividing with quotient of powers, I'm subtracting the exponents, okay? And this property only works when I have the same base, okay? So that same base part of this is really important. If they don't have the same base, just like we learned yesterday, we can't apply quotient of powers property. It doesn't work. All right? But if they have the same base, quotient of powers says I can subtract, the order is important, the numerator minus the denominator. All right, so go ahead and write down these 4 problems and just leave about 2 spaces in between each problem. Okay, so just like we learned yesterday, when you are doing quotient of powers, you need to write, okay, we call the middle step the expanded form of, basically, what are you doing here to get to your answer? Well, just like with product of powers, we add the exponents. When it's quotient, when it's dividing, does everybody agree a fraction shows division? Okay, when I'm dividing exponents with the same base, I subtract the exponents. 2 to the 2nd power. And that's my answer. 2 to the 2nd power. Okay? But I need you guys to show this step right here. Okay? Actually, at some point you're going to do this mental math, and even towards the end of this lesson, you're going to do parts of it mental math. But I need you to show these steps, and really, guys, it'll help you. Okay? It'll help you just see exactly what you're doing. All right? The same concept applies with variables. Now, there are 26 letters in the alphabet. Everybody agree? The variable has to be the same letter. So if the top is an H and the bottom is a J, it doesn't work. They both have to be the same variable. Are they here? Are they? And yeah, they will be, because you can't practice the concept if they're not. H to the 7th minus 6 equals H to the 1st power, and we talked about this yesterday. Do we technically need the 1? No, you could just say H. Either answer would be acceptable, and you wouldn't not lose points on a quiz or a test. All right? Let's look at the next one. Negative 7 to the 9th power divided by negative 7 to the 3rd power. All right, so we could evaluate these, but you're going to end up with numbers in the hundreds of thousands, and that's not what it's asking you to do, okay? It's to say, okay, what's negative 7 to the 9th power? All we're doing here is simplifying the exponents. Do you agree that we have the same base? So all you do is write that common base, and then in the exponent, you're showing what you're subtracting. Again, the order matters. So you're going to see this later in Chapter 8, guys. it's always numerator minus denominator, even if that means it's going to be negative. It won't be in this lesson, though. They'll never be negative in this lesson, but they will be in a couple weeks, all right? So negative 7, 9 minus 3. What's 9 minus 3? Negative 7 to the 6th power. All right, I want you to try the last one. It's a decimal, but we treat it the same way because they have the same base. Do you need to write the exponent of 1? Nope. So 4.2, 6 minus 5 equals 4.2. Now, if you wrote the exponent of 1, again, just like we just said, that's okay. All right, any questions on example 1? Can you see the difference of when you're supposed to add the exponents and when you're supposed to subtract them? If you're multiplying the exponents, you add. If you're dividing, like we're seeing here in today's lesson, you would subtract them. Because what we're going to see in example 2 is a combination of the two. So how do you know when to add the exponents and how do you know when to subtract them? It's all about the operation. If you're multiplying, you add. If you're dividing, you subtract. Go ahead and write down these three expressions, and we're going to simplify them. And specifically, write our answer as a power. So when they say to write your answer as a power, that's like you're out, that you don't have to evaluate these, okay? It's not saying give an answer or evaluate. It's saying just write your answer as a power. Basically, simplify the exponents. On this slide, here's what we have to do. Before we can do quotient of powers, and really this makes our life so much easier, okay? There's actually 2 different ways you can simplify. But you guys mind if I only show you the easy way? Okay? All right, we're not going to make things more complicated than they need to be. I can simplify. I need to look. Can I simplify what's in the numerator or denominator before I divide to get my answer? Okay, well, what do you see in the numerator? You see multiplication and, more specifically, same base, right? So if you're multiplying same bases, what can you do to your exponents? Add, because it's multiplication. That multiplication tells me I add my exponents. So this part, I'm not going to make you show that step, okay? What is 4 plus 2? Can we do that in our head? 4 plus 2 is? So 3 to the 6th power. Everybody understand how we got 3 to the 6th? Now rewrite your denominator, okay? Now that we're here, I do want you to show 3 to the 6 minus 3, which is 3 to the 3rd power. You might be thinking, man, like, how do I know, like, when I need to show my steps and when I don't, okay? When it comes down to your quiz and your test, you're not necessarily going to lose points there if you get the correct answer, but while we're still learning these concepts, this is what really helps you kind of train your mind and if you're adding or subtracting. All right, I want you to try to simplify now this second problem here. X to the 4th times x to the 7th over x to the 5th. Again, before you divide, you need to check and make sure that everything in the numerator and denominator is simplified, okay? Then you can do quotient of powers and you can solve. Did anybody see something you could simplify? Anybody want to raise your hand and tell me? Anyone? Anyone? Any takers? Let's see. Sam, what'd you do? Can you simplify anything in this top right problem?
Yes.
What did you do?
Added the 4 and 7.
What'd you get? X to the 11th. Did you guys get that? Yeah. X to the 11th power over x to the 5th power. All right. How can we get to our answer now? Would we add 11 plus 5? Would we multiply? Would we subtract? What do we do? How do we know we subtract? Because it's division. 11 minus 5 equals x to the 6th power. Okay? X to the 6th power. All right. I want you to do this last one on your own. All right? What we see different here is where is the simplification part to it in the fraction? Where is it? It's in the bottom, which is the denominator, but we don't treat it any differently. We simplify, and then we do quotient of powers. All right, go ahead and do that. When you have the answer, raise your hand. 2 to the 15th. I think we were pretty much 100% on that, walking around just looking at your papers. Over 2 to the 8th equals 2 to the 15 minus 8, which is 2 to the 7th power. 2 to the 7th power. All right, any questions? Okay. This one obviously looks a little more complicated. We're just going to focus on these top two. We'll see how the top two go, and I'm not saying, oh, if you do terrible, you have to do more work. But I've got the other ones in there kind of more or less as cushion if we need more practice, but we're just going to focus on the top two problems for now. So just write the top two down. All right? All right, so one thing I need you to look at, okay? All right, obviously we have two fractions involving quotient of powers. But what do you notice about all the bases? They're all the same. So right there, that opens the door for quotient of powers. So what we're going to do is we're going to evaluate each fraction individually. Okay? Each fraction individually. So I'm going to apply quotient of powers. Okay? What is 9 minus 5 on the first one? 4. All right, so does everybody see where we got negative 4 to the 4th power? Everybody see that? So I just simplified the first fraction. Now I'm going to multiply it by the second fraction once I simplify that one. What's 8 minus 2? 6. So now it's times negative 4 to the 6th power, okay? And now you have product of powers. So you simplify your fractions, and now you multiply them together. Again, that operation tells you if you're adding or subtracting. Since I'm multiplying now, I add my exponents to get what? What would I get? Negative 4 to the 10th power. Okay, negative 4 to the 10th power. All right. Here's my next one. P to the 3rd times P to the 6th over P to the 2nd times P to the 4th over P. What do you notice about all the terms in that expression? They all have a base of P, which means quotient and product of powers, it's just a matter of getting the order right. So what we want to do is we want to simplify the first fraction and simplify the second fraction. Okay? Simplify your fractions first. All right, how could I simplify P to the 3rd times P to the 6th? What would it be? Addition, so what would it be?
It would be P9.
P to the 9th power over P to the 2nd power. And now we rewrite it times our second one, P to the 4th power over P. Okay? Now I'm ready to do my quotient of powers and simplify each fraction and then multiply. Go ahead and do that. What is 9 minus 2, guys? 7. So we have P to the 7th power times, is this 4 minus 0?
1.
It's 4 minus 1, the understood 1 there, guys. So 4 minus 1 is 3. P to the 3rd equals P to the 10th power. All right. I want you to do this third one. All right. I'm just going to walk around and kind of check how you guys are doing. All right. Simplify the fractions and then do your product of powers. What did you get when you simplified the first fraction? What'd you get? Someone raise your hand and tell me. What'd you get when you simplified the first one? Jakari? Okay, how do you say it? A to the 4th power, okay, times, what would be the second one once I simplify? Caleb? What's my second fraction once I simplified it? Okay, A to the 3rd power. Remember, guys, we say to the, and we say whatever it is, power. to the third power. So we need to practice saying those terms correctly. All right, so who can tell me what the answer is? Who can tell me? Ashlyn, what was my answer on that one? A to the, nope, not just A. We need to not subtract the exponents. How did we know we needed to add them? Because it's multiplication. So our answer would be what, guys? A to the 7th power. A to the 7th power. All right, so simplifying fractions where there's two quotient of powers and then we have to multiply. All right, that's about as hard as you'll see it on your homework tonight. I want to look at this problem together. Your friend simplifies the quotient. Are they correct? Yes or no? If the answer is yes, just say they did their properties right or their operations are correct. If the answer is no, tell me what they did wrong and what the correct answer would be. Right. Kendall, did she work this correctly? No. What did she do wrong? Okay. Yes. Okay, so the answer is no. You're supposed to subtract, not divide. Subtract exponents, not divide. All right? Just something along those lines. So when we do it correctly, 15 minus 5 is... 15 minus 5 is 6 to the 10th power. All right, guys, are we catching on? You guys going to be okay on your homework tonight? All right, you've got one more problem to figure out. Last hour, most of the students got this right. I want you to go ahead and solve this. I like kind of throwing out, obviously we have the pi symbol here, but our concepts are still the same, how we would solve this. I want you to try to come up with your answer and raise your hand when you have the answer. Okay, so we simplify what's in the denominator. What's 18 plus 4? How did I know to add my exponents? Because it was multiply over pi to the 22nd. And now that my exponents are in a division problem, I would subtract them to get pi to the 8th power. Who got that right? Pi to the 8th. Okay. All right. So that's everything you need to know for section 8.3 and the completion of our unit. That's it. Okay. So tomorrow's a review day. Monday we quiz. Tuesday we review. Wednesday everyone gets an A on their test. That's the plan. You guys go with that? Okay. So that's what we're going to go for. It's just now a matter of we've covered all the concepts. Now we need to go back through and make sure there's no confusion and kind of figure out what you're still messing up on.